Over the last 66 years, 15,146 objects have been launched into space. There were 8,161 satellites orbiting the Earth until January 2022, out of which only 4,852 were active satellites. But that changed when Starlink reported compiling launch data, which suggested that more than 5,000 satellites were already in orbit by the end of 2023, 42,000. That's how many satellites Musk has said he hopes will be in Starlink's constellation. The company is currently reportedly working towards a constellation of 12,000 satellites. Currently, traditional satellite internet services rely on a handful of large satellites positioned in geostationary orbit, thousands of miles above the Earth's surface. While effective in reaching remote areas, these systems suffer from significant latency issues due to the long distances involved. Moreover, the limited data capacity of individual satellites results in slower connection speeds and reduced reliability, especially in densely populated regions. Starlink seeks to overcome these challenges by launching thousands of smaller satellites into much closer orbits, ranging from 200 to 400 miles above the Earth. This proximity allows for faster data transmission and reduced latency, promising internet speeds comparable to or even surpassing those of terrestrial broadband services. The potential impact of Starlink extends beyond bridging the digital divide. Elon Musk envisions capturing a significant portion of the trillion-dollar global telecommunications market, with projected annual revenues of $30 to $50 billion for SpaceX. This revenue stream could not only sustain the development of Starlink, but also fund ambitious projects like Starship and the establishment of a Mars launch infrastructure. However, the rapid proliferation of satellites raises valid concerns, particularly within the scientific community. The reflective surfaces of Starlink satellites make them visible as bright streaks in the night sky, posing a challenge for astronomers conducting sky surveys to detect near-Earth objects and study celestial phenomena. Efforts to mitigate this interference, such as coating satellites with dark materials or adding visors, have had limited success. Moreover, the sheer volume of satellites in orbit increases the risk of collisions and the generation of space debris. A scenario known as the Kessler syndrome, where cascading collisions render space travel unsafe, looms as a potential consequence. While SpaceX claims its satellites are equipped to autonomously avoid collisions, the presence of disabled satellites poses a lingering threat. To address these concerns, regulatory bodies like the FCC are being urged to impose stricter regulations on satellite deployments in low Earth orbit. However, the competitive landscape is expanding, with companies like Amazon and OneWeb vying to establish their own global satellite networks. Without adequate oversight, the proliferation of satellites could encumber Earth's orbital space, jeopardizing future space exploration and scientific endeavors. In essence, while Starlink holds the promise of universal internet access and substantial economic benefits, its unchecked expansion underscores the urgent need for responsible stewardship of Earth's orbital environment. Balancing technological progress with environmental sustainability and scientific exploration will be paramount in shaping the future of space-based telecommunications. Thank you for watching. Hope you've learned something. If you have enjoyed this video, please give it a thumbs up so this video may reach a broader audience.